Hello folks, and welcome back to another tutorial on multi-scale gradient removal, but this time for star fields. I know it's not conventional wisdom, but I tend to have clear nights strung together right around full moon for some reason, and so I will shoot narrowband mostly, but I do like to squeeze in a little bit of broadband imaging on star fields specifically. I like to shoot double stars, star clusters, and so I try to squeeze those in when I can, but that typically is right around full moon. You can keep the exposure times short, so it's not a big deal, and I'm not worried about capturing the faintest details in galaxies or nebulosity and things like that, so it works out pretty well usually. But this time around I've come across some pretty interesting gradients, and building on the multi-scale gradient methodology that I went over in the first video I released on the channel, I was toying around with some ideas on accurately subtracting out the gradients from these images. This is Alboreo here on the left in this panel, panel 1, and then another field to the right of it, because I'd like to make a two-panel mosaic this year. Alboreo is one of those beautiful double stars, and so I like to come back to it each season. It's the head star for the Swan Cygnus constellation. And so when it rises around this time, high in the sky, about middle of the night, I like to try to capture it. This year though, clear weather was around the full moon, and I did have some high clouds. This data was taken a couple nights apart, and in trying to process it, DVE is going to do a fine job. I think you just have to toy with the settings and go back and forth and iterate a bunch. And I found a couple of times that if you're not careful, you can get to the point where you're making the image non-linear, you're stretching it, and you can come up with some color gradients in the background. So while you could do DBE here, I found, in thinking about the multi-scale gradient removal process, I think I've found a pretty accurate way of getting rid of the gradients here. Now, this methodology might be out there, somebody might have done a video on it already, but I haven't been able to find anything on it. So I'm not going to claim this as, my own MSGR methodology or anything like that. I'm sure somebody's come up with something like this, but because in working with these panels, kind of came across this technique, I wanted to put a video out for those that do image star fields, star clusters, and double stars like this, to get a very accurate gradient removal. So let's jump into the process here. Real quick, I would encourage you to go back and watch the video on MSGR. I'm not going to delve into the methodology in this video, so I'm not going to go into the processes and explain them like I do in the first video. So to get the idea behind what we're doing, I would encourage you to watch that video. In the description of that video, you'll also have access to these process icons here, so I would encourage you to grab those, and that way you can walk through this tutorial with me. This sort of a process is made possible by star removal tools, and so I'm going to use Star Exterminator today. You can use StarNet or StarNet 2, just something that will pull the stars out easily for you. But I'm not sure how you would do this before star removal tools, but because we have that here in modern astronomy image processing, we can do something like this. So I'm going to go ahead and put panel 2 aside for now. And the first thing we're going to do is make a copy of panel 1, and we'll get a star removal out. Like I said, I'm going to use Star Exterminator here, and we'll go ahead and remove the stars from the copy. Alright, and there we are, left over with those background gradients there. But really what we're left with is the noise pattern and these large scale gradients. So what we can do from this point is get out multi-scale median transform, and in the original video I said that I like to stick around 7 layers to remove, but in this video I think we can go down to 6 layers here, and we're going to remove all the small scale stuff from this image and be left over with the large scale gradients. That worked really well. That's what we're expecting to get. And when we compare the images before we do any sort of subtraction here, we are seeing gradients modeled accurately. So we see this magenta circle here in the center, this greenish white outer area here with this white band here. This is why I think I had some high clouds here. So nonetheless, the gradients are modeled accurately here. So with these MSGR icons, we can go ahead and name the field we want to correct T1, and that's because the subtraction math is going to call T1 as a name, and we can name the model, well, model. And then once those are named, we can then drop T1 subtraction on the field we want to correct, and you can see here this is a phenomenal subtraction here. Go ahead and do an extra auto stretch there, and then I like to do a boosted auto stretch just to see if there's any residual color gradients. We don't have any here. We are seeing a little bit of green there, but that's because that's in the noise, and this methodology is not going to affect the noise. So let's get a regular auto stretch, and then I want to show that real quickly that we blink back and forth and show that the noise pattern is not being changed at all. We are affecting those gradients, but the noise and the stars stay the same. So a very accurate, phenomenal correction from that to this. And because this is a 2-panel mosaic, we'll go ahead and remove the gradients from the second panel. I'll need to rename that because that's going to trip me up here in a second. We'll get rid of model, and let's get that second panel out. This data was taken a couple nights after the first panel. The moon was fuller at this time, so the gradients are different, but the process is the same. We'll make a copy. We'll get rid of the stars. And now with the stars removed, we can go ahead and remove the small scale information. I'll keep it at 6 layers. That works pretty well for this stuff. We want to be left with those large scale gradients, so 6 layers is working out fine. And you can see we've removed all the noise and small scale stuff from the image. So looking at the gradients before we do the subtraction, they're modeled accurately. We have the light fall off from right to left, green in the upper portion of the image, and magenta in the lower portion. So let's just make sure that we name the panels correctly, T1 and model, and then we can just drag and drop the T1 subtraction for a flawless gradient removal there. Another regular auto stretch. Let's get a boosted one going to show that we really don't have any color gradients left over after the subtraction. And just check the noise profile as a logic check to make sure. And although we do remove the gradient there, the noise profile stays the same. So noise and the stars stay the same, and the large scale gradients get removed. And just as a quick aside, there's an easier way to do this. I know this is a pretty quick way of removing gradients, but there is an easier way where we can utilize a process container and input the processes into the container. We have star exterminator here, multi-scale median transform, and then the image identifier to model. And if we're dealing with the gradients and we want to make it a little bit faster, or just easier I should say, we can just make that copy, drag and drop the process container onto that copy. It'll run through each of those processes in the order that they're placed in the container, and then it will produce the image at the end. So we're effectively doing the star removal, the multi-scale median transform removal, and we are changing the image name to model, and we're getting back the exact same model that we just created a few moments ago. And so with this panel still named T1 and this one named model, we can just drag and drop the T1 pixel math and get back that flawless corrected image there. So 2 very well corrected images, a very simple but I would say profound way of removing nasty gradients from light polluted skies, full moon skies, things like that, where you're just imaging star fields. Now that's really the key to why this works. We don't need the wide field image because we're not dealing with trying to subtract out target signal like a galaxy or a nebula, so we don't have to create that intensity map from a wide field image. We can literally just remove the stars, remove the small scale information from that model, and then subtract off those large scale the large scale gradient information from the main images. And so this is a very powerful method to remove gradients from star fields. I hope this works for you. I can't wait to see what you guys come up with. You know, I think that star fields, double stars and star clusters don't get much love, so I hope this gradient method will help you to get out and shoot some of those targets, even if it is nearing full moon for you. And looking forward to what you guys get. So that's the method in a nutshell. As always, if you have any questions, leave a comment below. You can get a hold of me on Discord as the_revisionist. And so happy processing and clear skies.